Okay, in this video we're going to take a look how to take the derivative of a power function. So let us briefly take a look at what the power function is. So let us say our function f as a function of x is equals to x squared, right? This is a power function, or another one would be that g of x is equals to x to the power n. So what we're going to do is we're going to first derive the derivative of the first one, x squared, and then we're going to generalize this to the general power function, right? So let us recapitulate the derivative of the derivative. So f prime of x is df by dx, and this is f of x plus h minus f of x divided by h, right? And that's in the limit as h tends to 0, right? So let's now insert our function x squared here. So now we're going to use that f of x is x squared. So this is going to be the limit as h tends to 0 of x plus h squared minus x squared, right? Because here the argument is x plus h, so we have to take x plus h squared, and here the argument is only x, so we have to take only x squared, right? Divided by h, right? And now this is the limit as h tends to 0 of, and now we're going to use the binomial formula, right? So this is x squared plus 2xh plus h squared minus x squared divided by h. And now immediately you see the x squared cancels, right? And then also this h and this h squared here cancels with this h. So what we're left with is the limit as h tends to 0 of 2x plus h, right? Now, and this is obviously just equals to 2x. So the derivative, so d by dx of f of x is d by dx of x squared is equals to 2x, right? This is the this is the derivative of x squared, right? So now what we're going to do is we're going to generalize this result now to x to the power n. So let us take now the derivative of g, right? We call it g. So we're going to say g prime of x is dg by dx, which is g as a function of x plus h minus g of x divided by h in the limit as h tends to 0, and this is equals to what? This is going to be equals to x plus h to the power n minus x to the power n divided by h, and of course in the limit as h tends to 0. Now this is equals to, we can now use the binomial formula, right? So x plus h to the power n is just the sum as k goes from 0 to n over k, x to the n minus k, h to the power k. We have to be careful so that we do not h minus k, right? And then all of this in brackets minus x to the power n divided by h. Let us write down the first few terms of this sum here. So that is just, let me write it out clearly, n over k. So this is n upon 0 times x to the n times h to the 0 plus n upon 1 times x to the n minus 1 h1 plus n upon 2 x to the n minus 2 times h to the power 2, and so on. minus x to the power n. All of that divided by h, and of course in the limit as h tends to 0. Right. Now what you first notice here is that n upon 0 is just 1, right? Brief excursion. N upon k is equals to n factorial over k factorial over n minus k factorial. So n upon 0 is just n factorial over 0 factorial times n factorial, and that's just equals to 1, because 0 factorial is defined to be equals to 1. There might be some reason why it's actually so, but that's beyond the scope of this course, beyond the scope of this video. So this guy is equals to 1, h to the power 0 is equals to 1, so this cancels with this, right? And then we find that this h, because this is 1h, h to the power 1 cancels with this, and then all of these h's become this 2 becomes a 1, and then you have h to the power 3, which becomes 2, and so on, right? And that goes all the way up to n. But what you notice is that the first term and the last term here have cancelled. These two terms have cancelled, and now this term is the only term which, when you divide by h, has no power of h. The other terms all have powers of h, right? So when you take the limit as h tends to 0, all these terms vanish, and what remains is only this term over here. So what remains is that this is equals to n over 1 x to the power n minus 1. That's it. And this is n factorial over 1 factorial over n minus 1 factorial. Now 1 factorial, this is equals to 1, and n factorial over n minus 1 factorial, sorry, x n minus 1, and this is equals to n factorial over n minus 1 factorial is n, right? Because this is n times n minus 1 times n minus 2 and so on, divided by n minus 1 times n minus 2 and so on, and all these terms here cancel. All these terms will cancel, and what remains is only the n. So what remains is that this is equals to n times x to the power n minus 1. That's it. That's the answer. So we have derived the general derivative for the power law for actually only for integer powers, but it also applies for rational powers and so on, but that's more complicated to do. But yeah, so we have n to the x to the power n minus, yeah, that's it. So thank you for watching.